Recording in progress.
You can see the screen? Yeah.
Yes, it's clear.
So moving on, and before I get to the basic examples, it is important to share the underlying discussions, the most important discussions, which is not easy in terms of well, the court said find a way, but then how do you actually translate that into reality, and what are the challenges that really face such situations? So the ancient temples that we are talking about, these are not archaeological sites. These are they have archaeological importance, but they're not archaeological sites. So it is difficult to freeze them. They're living monuments. They're living temples. It's difficult to freeze them, in time. So like an archaeological site. So in reality, what are these big challenges that we're looking at? Since these are living monuments, there is a continuation of the original function of the site, and that's really the legacy of such sites. And then these temples might have been around for, the sites might have actually been around for even 2000 years, because there is reference to some of the early literature, reference in the early literature to these sites. So these have been part of the culture, the spiritual activities, the spiritual development of the entire region over centuries. So question, is it possible to say we will take an archaeological approach of conservation in these sites and these monuments? It may not really work always in the living ancient temples. Where is the archaeological interest coming from in such temples? Now, the archaeological interest is really to protect the fabric, because the fabric, what remains of the fabric is crucial to understand the evolution of architecture, of history in those regions. So it's really the object of archaeological evidence. And so you see that on one side, you need continuation of the functioning of the site. On the other side, you really need to preserve it, because the object is a part of archaeological evidence. Culturally and from a religious perspective, what is really happening? The purpose of the temple is to cater to the spiritual dimension of people. And that's why people come to the temple, right? So if you tell them, no, we have to preserve it for archaeology, it's not something that people will appreciate immediately. So that's a paradox that we already face. Now, temples have as their primary purpose the witness of faith. They were built for faith, and it was not built for archaeology. It was built for faith. So that's a fundamental aspect that we must keep in mind. But it is true that some of these have been around for so long that it's part of the historical development, evolution of a particular place. And therefore, it needs to be recognized that it is no longer a single stakeholder, it is a multi-stakeholder environment. And that's really the paradigm shift. It is difficult to accept that a temple has to also cater to archaeological requirements, and those requirements may be different from what the requirements of the cultural or the religious interest might be. And therefore, a middle path really needs to be evolved, addressing both the cultural and the religious sentiments and the archaeological requirements. And this is easier said than done. And so what are the challenges that we would face? But one aspect that we sort of need to keep in mind is that in a country like India, the concept of conserving and protecting temple structures is not something new. While conservation as a field is rather new, preserving temples and maintaining temples is not something that is a 20th century concept. Conservation engineering, conservation architecture may be a new field, but that's similar to architecture or engineering. It's not that in the ancient past, our ancestors were not building and our ancestors were not preserving things. So the principles of protecting temples, the principles of renovating temples, the word that actually encapsulates that is Jirnodharna. Jirnodharna comes from the word Jirna is something that is getting damaged over time. And the whole process that caters to reducing the damage in the temple or any built form is called Jirnodharna. So renovation of the existing temple is what is enshrined in many of these principles which have been followed for centuries. Ancient texts actually dedicate an entire chapter to what is acceptable, what is not acceptable. So the concept of conservation really is something that people have been doing for centuries. And it's very interesting that if we read the ancient texts, we do see that the approach prescribed was actually a minimalistic approach. It never said, if you see a crack on a single stone, change the whole wall. They were really very clear. If you see a single crack, you attend to the crack in that stone. So the minimalistic approach concept for repairs and renovations was actually enshrined in these principles. And then we also need to get into the philosophical understanding of permanence and change in a spiritual environment, and that particularly in the religion that we're talking of here, it is understood that there is always a cycle of life and death, and the temple renovation is also part of that process. And you cannot freeze anything in time. You cannot just freeze it and expect it to just last forever. Nothing lasts forever, and therefore embracing change for continuity of the spiritual development is something that is clearly recognized, that you will have to keep intervening to ensure that it continues. And that is what the temple itself is meant for. However, if you were to examine the modern tenets of conservation, it is so wholly focused on preserving the ancient physical fabric. There's so much of interest in saying that there is value to the ancient physical fabric and you must preserve it from loss and depletion, and minimal intervention comes in that context. But that's not explicitly stated in the way Jirnodharna is understood. Jirnodharna says if you really need to replace it, you can replace it, because continuity of the spiritual development is what is the central requirement. Now, if you bring in the archaeological perspective, you talk of authenticity and the historicity of the original materials, and that will take precedence over renovating a space simply because it is meant to be for a certain cultural practice or certain religious practice. So while essentially there is an overlap between how these principles have developed, there are also conflicts. And that I think we must keep in mind. So a conscious application of this concept of minimal intervention on the physical fabric needs to be carried out while you encourage the continuance of the witness of faith in a living temple. So the place needs to be continued to be in continued use, but that doesn't mean that you keep renovating as much as you like. Be sure that you're actually minimal in your intervention, and this is really what the essence of these principles really imply. So if you look at what should you do in terms of the approach to conservation and management of the built heritage in living temples, it is a complex multidisciplinary space. It is important to bring in the rules and the practices that have already been set forth in the traditional knowledge systems. And my reference here is there are texts written, they are called the Agama Shastras, the Sthapatya Veda, that the signs that the Sthapatis follow, and the Shilpa Shastras, which take care of all the other art and craft forms, for example, the idols, the paintings. So all these are actually already codified in the traditional knowledge system. In the modern conservation and management of such built environment, it is important to bring in this traditional knowledge system. And in this context, there are two important personalities which also have an indispensable role, One is the Acharya, who is the person who is performing the rituals in the temple and is knowledgeable on how the temple is built, where the materials are to be sourced, and how the rituals and practices are carried out and why they are carried out. He is the teacher. And then you have the Stapati, who is the builder. These two people cannot be taken out of the renovation work that actually happens in any of these temples. That is how it is different from any other historical monument or any other archaeological monument that you're dealing with. So therefore, you really need a confluence of good practices from conservation engineering and the traditional practices, because while you're trying to preserve the tangible, the built form, it is so important to be careful that we're also preserving the intangible cultural heritage, which is the traditional knowledge system of how these temples are built, what material is used, why they are used, how they are used, and the rituals that are related to it in the whole cultural context. So that's what it is. And therefore, it is our understanding today that, look, we cannot repair temples or reconstruct temples, but we can only conserve these traditional temples. And, such a large body of structures that I was talking about, 40,000 of them, but 9,000 of them being old, even a listing and grading exercise has not been completed for such a large number of temples. So it is really important to learn these from the modern conservation principles and then try and apply it for the ancient constructions. And also a consultative process needs to be carried out where you have multiple stakeholders. And as I said, it should be these teachers, the Agama experts, the people who work with icons, idols, the Stapatis, archaeologists, conservation experts, architects, civil and structural engineers, temple administrators, devotees, donors, and the local community to be able to work in such contexts. And the reason why we have to be very careful about this is today there is ever-growing demand from the public and the temple administration to keep increasing amenities, keep increasing public places for the public to come and pray, to come and devote to religion. So there is always a need to upgrade the pilgrim infrastructure to ensure the safety of so many pilgrims who come in. It is important to have infrastructure that actually caters to large crowds and is not, becoming a safety issue as well. And then you basically have, you really need to draw a line as to where is the acceptable intervention in such precincts. And to be able to do that, there must be a conservation master plan for the ancient temple precinct and go by that, go by the ancient temple, go by the master plan for such premises. And in today's context, we also have to adopt sustainable and environmentally conscious approaches, which can be brought into such contexts. As I said, it's not only the tangible, it's also the intangible. The traditional knowledge system has been passed on through several generations. And unless we make an effort to bring them into the mainstream and ensure that that is also preserved, the traditional knowledge system will be lost and the intangible cultural heritage would actually be lost in these living temples. So this is really the context. And I would like to take the next, I would say, 20 minutes or 30 minutes or so to, if that's available, to look at 3 different examples which have different focuses, but are related to this issue of how do you combine these seemingly opposing requirements of archaeological importance and amenities and the continuation of the faith, which is the function of the temple itself. So that's what I'm going to look at. 3 cases, as I said, they're very different cases, and I'll go over them quite quickly. But I have 3 different publications that actually talk about all these 3 all these 3 conservation exercises. And hence, at a later stage, if there are specific questions, you could look at the documents and then come back for clarifications. So the first one is of a very famous temple called the Madurai Meenakshi Sundareshwar temple, which was part of this temple was affected in the fire. Of course, most of these temples have grown over a long period of time, and they've organically grown into very large complexes. This particular temple, in the initial constructions were in the 12th century, but then there were additions even in the late 19th century. So, over a large period of time, you have these constructions. I am going to focus on a structure that is, I hope you can see the pointer. You have what is called, it's a hypostyle hall. It is called a mandapam. And this was damaged by fire. And you can see that it is sitting next to a very, very large complex. It's referred to as a 1,000-pillared hall, and it's a massive construction. It's sort of the pride of the place. It's a beautiful construction. The fire affected this location, but could have endangered this very famous construction as well. So that's the context. The name of the mandapam is Vasantarayar Mandapam, Veera Vasantarayar Mandapam, in honor of a person by the name Vasantarayar, Veera Vasantarayar. And the person was the brother of the king who was ruling at that point in time. So built in 1611. It's a hypostyle hall, and it's actually a multifunctional hall inside the temple. And today, not only this mandap, but also many other locations in the temple which are similar, are used for multiple things. For example, a lot of shops selling products that are for the religious activity or otherwise were housed here, and the vendors would have to pay a small rent to the temple department to have their shops there. And so you can actually see that a lot of the sculptural beauty of these spaces is obscured by the shops, but that comes from the fact that these were multifunctional spaces. So one night in this particular construction, after the shops were all closed, there are about 40 to 50 shops within this construction. What I'm showing you is a plan of the structure. On a Friday night, since this is a temple dedicated to the goddess, Friday is an auspicious day, and on Friday night, after the affairs of the temple are completed, the shops are also closed, and there is a ritual that they carry out in each of these precincts where shops are present to remove the bad eye. They would just use a pumpkin with a camphor on it and show the shop this pumpkin and camphor, and then break the pumpkin. And in the process, what actually happened in this location, because closed circuit cameras, CCTV cameras were present, it was clearly visible that after the pumpkin was broken, the lit camphor actually spreads all over and goes into one of the shops. And about 15-20 minutes later, the camera starts showing there's a lot of white smoke that's obscuring the camera. And in a few minutes, the whole place is up in flames. And since the space was full of so much of material, clothes and plastic and, shops selling all this material, the fire went on for close to 5 hours. So we are talking of about 10:30 in the afternoon, 10:30 in the night, to about 4 o'clock in the morning. The fire could not be curtailed. In fact, the fire department struggled to control the fire because of the amount of flammable material. And eventually, only after the collapse of the roof could the fire become less concentrated, and therefore they were able to bring down the fire here. So the pictures that you see here are after the fire, and you can see so this is a granite construction, to give you the context. And for us, when we started working on this, to see granite perform the way it did under fire was shocking. Because what you see is the collapse of the roof. It's a roof construction with stone, and above that you have brick and lime concrete. But then rest of the construction is stone constructions. And I'll show you some pictures which will make you realize that stone had just melted like any other material. Again, pictures of the day after the collapse. And you can actually see here how the roof caved in. And you can see how stone beams and stone columns have just melted out of shape. So you're looking at material like granite, which is considered to be the strongest of the varieties of stone, that literally melted in this fire. Again, you can see these are all sculpted, heavily sculpted columns that have just rounded off because of the heat. And with the collapse of one part of the roof, there is a sudden destabilizing effect in the columns, and some of them even ended up cracking. So there was very heavy damage in this structure, which had about 115 columns, 115 stone pillars. One aspect when you look at these columns affected by the fire, you can actually see flaking. The stone just comes off in layers. You can actually with your hand remove layers, which means the load carrying capacity is quite seriously compromised in the stone that is really near the in contact with the fire. So the primary concerns here was right next to this structure was the 1,000-pillared structure, which is a sculptural marvel right next to it. So the biggest concern was if this were to collapse, if the fire-affected monument was to collapse, would it damage the 1,000-pillared monument, which would be a massive loss because the sculptural quality in the 1,000-pillared hall is spectacular. The second thing was now you have this 115 pillared structure. What is its residual strength? Part of the roof has come down. We can see that several columns have been badly affected. But what is the status of this structure? Is it safe? Can we continue using it? And should the structure be used at all? Should we just pull down the entire historical structure and construct something new in its place? So that was the dilemma. And there was an expert committee that was called to look at it. And there was a multidisciplinary group, as stated earlier, which was trying to understand what can be done. But the concern also was the stone in this particular structure had seen a lot of deterioration over time. Not all of the stones, but some of the pillars had seen a lot of deterioration. You can see that the sculptural quality was lost because of the surface deterioration in some of the pillars. So the temple department was of the opinion that the original structure was already in a condition of extensive weathering, and the fire has caused further damage. So possibly it is a good time to completely replace this old mandapam from 1611. That was the situation. So the first things that were done was, of course, to ensure that eventual collapse of the structure does not affect the neighboring construction, which would be a big loss. And therefore, padding with sand, padding with soft material that will ensure that any collapse, any untoward collapse does not cause debris and heavy material to fall onto the other sculptural structure. The other mandapam was an important step that was taken. Another important step that was taken was since the roof was contiguous between the 1,000-pillared mandapam and the one that was affected by fire, at the roof level, a cut was made with a diamond drill bit. A cut was completely made so that if and when portions of the fire-affected structure was being dismantled, it does not cause vibrations and it does not pass on movements to the other structure. So what you see here is actually a cut that was with using mechanical cutters. And then you can see an attempt to sort of cushion the ends of the other structure from any imminent collapse. The sizes of the columns, sizes of the stone members were such that the use of heavy equipment was necessitated to even clear debris, and therefore these had to be operated at low velocity. I mean, at such low speeds such that the vibrations do not get transmitted, but work could not progress without the use of heavy machinery and heavy equipment. So at this juncture, when one of the ideas on the table was that the entire mandapam of 1611 should be toned down because it is very badly affected by the fire. the counter view was, are we sure that the entire structure is unstable? Shouldn't we do a detailed set of investigations to understand what is the status of damage, and then take a call on what percentage of the structure can be replaced with a new structure and how much of it can be preserved. So this was a real dialogue between the temple administrators, the temple builders, the sthapatis, versus the archaeologists, and the conservation experts who wanted to preserve, while the temple actually wanted to develop a new mandapam in its place. So we were involved, our department, our institute was involved in this context, and we said, let's before we arrive at the strategy for rehabilitation, let us look at the condition of the structure and document through visual inspections, but also document through non-destructive testing and multiple laboratory tests on extracted material, and carry out some destructive tests also if necessary. And what you see here is a picture of all the locations where these samples were taken. Visual inspection was actually complete. The entire structure was documented, but in terms of the non-destructive testing and laboratory testing, this had to be a few samples, but representative enough. So as you can see, the non-destructive testing technique that we finally used was ultrasonic pulse velocity. The infrared thermography, IR thermography did not really work in this context. Laboratory tests on extracted materials, microanalytical tests were conducted, such as X-ray diffraction studies on the material, porosimetry using mercury intrusion porosimetry. We did scanning electron microscope imagery on the stones. And then we also extracted some stone cubes from columns which were damaged at different levels, and did compression testing on these extracted samples as well. So the visual inspection gave us, I'm showing you some slides that give you an overview. As I said, this is there in a paper, a lot of details, but then I tried to give you an overview of what was done. So visual inspection was done for the columns. We classified them as columns with no damage, columns with minor damage, with moderate damage, major damage, and extreme damage. A column subjected to axial loads is in compression, and then it is subjected to fire. Whereas a beam or a slab is in bending, and then it is subjected to fire. So the way these two members really behave is quite different. And so it was important to understand different members, carefully. So we did that for columns. We did that for different beams. The red, the green, and the yellow are different stages of deterioration of these members. We did that for the slabs. You can see the kind of percentages. But what's important is this last overall assessment based on visual inspections, which said that the columns, we had, you see the no damage, and then the minor, moderate, major, and extreme. So if you add up the moderate damage, major damage, and extreme damage, you can see that we are close to 40% of the columns that are in moderate, major to extreme damage. If you look at the beams, we are at about 45% of the beams that are in moderate to extreme damage. If you look at the slabs, we are at about 70% of the slabs that are in extreme damage condition, moderate to extreme damage condition. So this gave us an idea from only visual inspections that about 50% of this structure is in really bad condition and may not be in a position to be reused. We then carried out multiple tests. We did some ultrasonic pulse velocity tests. The ultrasonic pulse velocity test gave us an idea that it was very surprising that the stone columns which were affected by fire and the stone columns not affected by fire did not show big difference in the velocity of the sonic waves. And that was a little counterintuitive. And if you actually see the fire unaffected and the fire affected columns, the numbers, which are really the wave velocities, are not very different. So this was a little bit of a surprise for us. So we went ahead, we did testing of some columns had collapsed. So we could take samples from it. We took samples from different parts of such affected members, and we did compression tests in the laboratory. And we realized that strictly speaking, the compressive strength of this granite was not lost in some of these columns. If we were to take a column that was very badly affected by fire, but take the core of the stone and check the compressive strength of the stone, it was really not compromised. But then outer layers, as I was mentioning, was flaking. And so we had to be careful that the section of the columns was reducing, and you could have buckling of these columns. So that point in mind, the compressive strength of the columns was really not compromised. So this is something that we were able to look at. We then, as I said, for the microanalytical studies, collected samples from different locations in the columns. And, we looked at columns that are affected, not affected at all, columns that are affected in a minor way, major way, extreme way. And I was mentioning some of the columns were already weathered before the fire. So we took some samples from that. We took some samples of new granite as well, so that we are able to compare the microscopic condition of the samples. The microanalytical studies were very interesting. We were able to see how the fire was actually this particular test called mercury intrusion porosimetry. Yes, I'll do same as before. So this particular test called mercury intrusion porosimetry is mercury is being under pressure, filled into the pores of a sample of granite. And you take measurements of how much of mercury is being used up. And at those measurements can give you an idea of the pore size distribution and the sizes of pores. And it was very interesting to see how the fire had actually affected the outer layers of the stone quite significantly, whereas the inner layers of the stone were more or less conserved. Small pores were beginning to join larger pores, and there was a change in the micro pore structure in the outer portions of the stone, not so much in the inner portions of the stone. So we were able to see that the columns that were possibly affected in a minor way or in a moderate way still had good core strength, which we can depend on. So that was some sort of an insight we were able to get. And in certain cases, the pore size was also changing because of expansion of some materials. So this was some insight we were able to get in different locations of the stone, in different stages of the fire damage of the stone itself. We then did X-ray diffraction studies to understand the type of crystals and minerals that are forming in the stones affected by fire. But here, really what was happening is the crystal forms were slightly changing, and that was due to expansion due to fire, and that was being captured, and that could also explain why the porosity was getting affected in some parts of the stone. What was interesting was to look at these scanning electron microscope images, and in the scanning electron microscope images, we started seeing depositions of ferric oxide, which was an interesting point to be noted, that ferrous oxide is what you have in granite as the mineral, but the conversion of ferrous oxide to ferric oxide by oxidation in the presence of fire was actually happening, and that happens at about 600 degrees centigrade. So there was evidence of presence of ferric oxide in many of these samples, which gave us the evidence of many locations which were in extremely, from moderate to extreme damage conditions of having reached at least 600 degrees or higher. And that was important to understand which were the more affected columns and which were the less affected columns, and few mineral forms that were typically seen because of this enlargement of the quartz as well. These scanning electron microscope images plus the XRD and the other tests that were conducted, the non-destructive tests that were conducted, along with the tests on the cubes, gave us some fundamental inferences. And I'll just take you through some of these inferences. from the visual assessment, we were able to arrive at the fact that about 54% of these pillars were damaged, and many of them were in the moderate damage to extreme damage category. So about 50% of the structure is in a bad condition, was clear. About 46% of the pillars were undamaged in the fire, and about 70% slabs were in major and extreme damage condition, whereas in beams, about 45% was in extreme to moderate damage categories. Now, from the non-destructive tests, we did not see any reduction in the sonic waves in the fire-affected pillars. That was, we expected it to have some changes in the sonic wave velocities, but this was not happening. And that was really because of the small sizes of pores that we're talking of in granite, and sonic velocity not being able to discern the difference between pores that are affected and pores that are not affected. But it was very clear that this was coming across because the core of the granite pillars were intact. It was really the exterior layers that were badly affected by the fire. And given the low porosity, the exterior layers were getting damaged by flaking. But the core of the granite pillars, in most cases, were intact. And the compressive strength tests also showed that the core strength was actually conserved, and this was an important outcome. The load carrying capacity, because these pillars had not reduced in cross section in about 50% of the cases, the load carrying capacity was really not affected in 50%, almost 50% of the structure. The microanalytical studies, we were able to see that the mineralogy really did not change. There was change of form of some of these materials like quartz, and that brought in some volume changes, and these volume changes caused some cracking, and that's why we were seeing some porosity changes as well. Again, the core of the heavily damaged columns, very slight change due to the fire was observed. But we had seen oxidation of iron, as I said, ferrous to ferric oxide. We had seen oxidation of the iron in all the fire damage samples, irrespective of the damage category, meaning that minimum temperature of 600 degrees was reached in all the columns in the site. And as I said, we were also examining the weathered columns with the extreme fire-affected columns. The weathered columns and the fire-affected columns are actually comparable in terms of their damage. So final conclusion, maybe I will stop and then close this discussion with as I begin in the next. Is that okay? And how are we doing in terms of time?
Yes, it's okay, and it's fascinating. I'm really very impressed by what I'm learning today. It's really
within the next 20 minutes or so, I'll conclude the rest of the discussion. Yeah.
Okay.
Thank you.
Okay. See you later.
Yeah.